So early morning, today we are going to discuss very important topic, that is voltage and current sources. Network theory lecture 03. Okay, again na lecture 3 में. So what about the first and second lectures? Everything is clear? Basics of network, guys. Basics of network. So everyone please join session now. तो चलिए start करते हैं without any delay. Now guys, this is a network theory lecture 03 voltage and current sources. आज हम लोग ये डिस्कस करने वाले हैं कि voltage and current sources dependent, independent voltage and current sources. When the two voltage sources are connected in series, then what is the resultant? When two voltage sources are connected in parallel, voltage source and current sources are connected in parallel, voltage or current sources are connected in series. And what is the source transformation from voltage source to current source, and how we can use this concept to solve questions, guys. Okay, तो एवरीवन एक बार जरा यस और नो लिखिए यार, कितने लोग प्रेजेंट है पता तो चले. चैट वेट अच्छा चल रहा है, साउंड क्वालिटी, पिक्चर क्वालिटी, एवरीथिंग इज फाइन. ओके ओके डन. इफ देयर इज एनी प्रॉब्लम देन प्लीज इन्फॉर्म मी. तो नेटवर्क थ्योरी लेक्चर 3 देन. ओके डन. So this is introduction. Sanjay Rathi, 24 years of teaching experience. These are my achievements. These are my ranks in engineering services exam. AIR 16 in ECE 2005 and AIR 21 in ECE 2008. And I have trained more than 1 lakh students for various competitive exams. I worked as Deputy Director in Ministry of Power, and these are my areas. Okay. And you can also join my Telegram channel. You can scan it. देन ये है इंपॉर्टेंट इंस्ट्रक्शन. अभी भी थर्ड डे है. दिस इज मस्ट पेन एंड नोटबुक. कैलकुलेटर इज नॉट अलाउड इन व्हाट दिस एग्जाम, इसरो एग्जाम, बट इट इज अलाउड इन व्हाट गेट एग्जामिनेशन. दैट्स व्हाई द प्लीज यूज पेन, नोट एंड कैलकुलेटर. रेगुलरिटी एंड पंक्चुअलिटी इसको मेंटेन कीजिए और ट्राई टू अटेंड व्हाट लाइव क्लासेस. एंड एट द एंड आई विल गिव यू द टाइम टू आस्क योर डाउट्स. तो बीच बीच में चैट लिखोगे तो आपका क्वेश्चन मेरे से मिस हो जाएगा. और अगर आपका कोई भी क्विजेस चल रहा है, कोई भी टेस्ट सीरीज है, तो रेगुलर इंटरवल पर वो जरूर दीजिए. कोई भी मिस नहीं करेगा. पेंडिंग करोगे काम, आज का काम कल पे डालोगे, कल का काम परसों पे, तो कभी नहीं हो पाएगा कोर्स. तो जो भी आपको टास्क दिया जाता है एज ए स्टूडेंट, आपका एक ही काम है, एक ही काम है, एक ही काम है, पढ़ना. ठीक है ना. और विदाउट व्हाट अबाउट द रिजल्ट्स, कोई रिजल्ट्स की परवाह मत करो. रिजल्ट्स आते हैं, कुछ करोगे तो आना ही आना है. ओके. तो चलिए देखते हैं आइडियल इंडिपेंडेंट सोर्सेज. एट द एंड वी विल सॉल्व द असाइनमेंट्स. ओके, वी विल सॉल्व द असाइनमेंट्स. आइडियल इंडिपेंडेंट सोर्सेज. देयर आर टू टाइप्स ऑफ एलिमेंट, पैसिव एंड व्हाट एक्टिव एलिमेंट्स. Already I have discussed passive elements, resistor, inductor and capacitor, series connection, parallel connection. Okay, now resistor is what? Dissipative elements. It can't store the energy. But what about the inductor and capacitor? They can store energy. They can store energy. So we have complete chapter on what? Inductor and capacitor. That is what? Transient. Transients. You heard about the transient? First order transient, second order transient. What will be the behavior of the capacitor and inductor? एक एक चीज बहुत डिटेल में we will discuss. ठीक है, तो वो होगा. नाउ आइडियल इंडिपेंडेंट सोर्सेस. तो जो अभी हम लोग देखें, ये एक्टिव एलिमेंट्स है. एक्टिव एलिमेंट्स मींस जो अपनी एनर्जी which are capable to produce their own energy. Okay, energy sources. Passive elements, they can't produce what? Energy, or energy, they are not energy sources. Then the first is what? Current source. Then second is what? Voltage source. So this is a very important. तो देखा है, an ideal independent source is an active element which provides a specified voltage or current that is completely independent of the other circuit element. It should be independent of the other circuit element. For example, what is the meaning of this? Now focus on the board. If it is a 5 volt voltage source, I am connecting a resistor. Okay. It doesn't matter what is the value of the resistor here, external resistor, the voltage across the resistor will remain 5 volt. It is independent of other elements. The 5 volt will remain 5 volt whether you are connecting the 1 ohm resistor, 10 ohm resistor, 10 kilo ohm resistor. This 5 volt will remain 5 volt. This is the ideal condition. This is what ideal condition. Similarly, this is a current source, let it is of 1 ampere. Suppose I am connecting any resistor here, the current will remain 1 ampere. Right? It doesn't matter what is the value of R. No doubt the voltage across the R will change, because what is the voltage? IR. In that case, okay, IR. So, but the current will remain same. Here the current will change. Here the current will change 5 by R. Why the current will change? Because R is variable. So in this case, current is variable, but the voltage will remain constant, fixed. It is independent of the variation in the resistor, and that is what called ideal condition. Are you getting my point? Ideal condition. Or that external resistor, in normal language we are saying that it is a load RL. So load, when there is a variation in the load but the value will not change. There is a variation in the load but the current source will not change. It will remain 1 ampere, or here it will remain same 5 volt. So that is the ideal situation. So what is the ideal current source and voltage sources? When I am talking about the ideal voltage source, ideal voltage source. Now, what is the ideal voltage source? Watch this. Okay. Now, ideal voltage source. This is Vs. Tell me, what is the ideal voltage source? What is ideal voltage source according to your definition? In interview they will ask, in ISRO interview they will ask, what do you mean by the ideal voltage source? Tell me. बोलोगे क्या? लिख दो भाई. What is the ideal voltage source? आइडियल वोल्टेज सोर्स का मतलब क्या है? तो नॉर्मली हम लोग 11th-12th में पढ़ते हैं ना, या 10th में, द इंटरनल वोल्टेज विल बी कांस्टेंट एवरीवेयर. ओके, हाँ, हम लोग पहले क्या पढ़ते थे? वो जो इंटरनल रेजिस्टेंस होता है वोल्टेज सोर्स का, दैट शुड बी इक्वल टू व्हाट? 0. हियर द इंटरनल वोल्टेज सोर्स, दैट शुड बी इक्वल टू व्हाट? 0. तो ये ना up to 10th class it is okay. RS should be equal to what? 0. But yes, your statement is correct. But RS is equal to 0. Internal resistance should be equal to 0. It is a secondary matter. What is the ideal voltage source? For example, this is the resistor. Now this is the current, load current. This is called load current. So load current is Vs upon RL. Vs upon RL, right? Now, first let the RL is what? Infinite. It is an open circuit. It is an open circuit. RL is infinity. Current is 0. Current 0 means there is no load. Remember, current is 0 means there is no loading. Loading depends upon what? Current. Current increases, loading increases. Or when the current will increase, when the RL will decrease. So RL is infinite. That's why the current is 0. No load. This is called no load condition. No load condition. There is no load. So what is the no load voltage? Vs. No load voltage is Vs. Under ideal condition, when it is open circuit, it is what? Vs. Now I am decreasing the RL. So what about the current? Increases. I am decreasing the RL. The what about the current? Increases. right? This is decreases, this is increases. But what about the voltage across the RL? It will remain same, Vs. It will remain same, Vs. There is no effect of loading. Loading means we are decreasing the RL, current will increase, circuit will load, and this is the voltage will remain constant across this one RL. ठीक है, तो that is called what? Terminal voltage. What is the voltage at this particular terminal? It is this A and this is B. It will remain same. Now, what will be the graph then for ideal voltage source? To graph for ideal voltage source, here it is, remember it is IL, load IL, right? Here the load voltage, this is called VL. This is called what voltage? This is called VL. Voltage across the load is called VL. No load voltage is VS. The VL will remain VL. VL will remain VS. There is no variation. That is called ideal condition. So this is the VL, this is the IL. I am increasing the IL, but the voltage will remain same. And that is what ideal condition. This is equivalent to what? Vs. When the current is zero, at this point always remember RL is infinite. When you are moving from this point to this point, RL decreases, current increases, but the voltage will remain constant, and that is the ideal current or ideal voltage source. Okay, first case, ideal voltage source. Second, यहाँ तक किसी को कोई doubt? Is it clear? No. So what about the practical voltage source then? What about the practical voltage source? So when I am talking about the practical voltage source, then I will conclude ideal and practical. So first focus on that. When I am talking about the practical voltage source, for example, you are using a battery, right? We are connecting the battery, but when we are connecting the battery to a particular what circuit, for example, I am using this mic. Is it visible to you, mic? Yeah, this wire is visible to you? Yes or no? So I am using the mic here, but from this point to that point, I am using a connecting wire. So when I am using the connecting wire, definitely the wire has some resistance, right? We can't ignore it, we can't neglect it. So when we are connecting the battery with the particular device, there will be the resistance, right? So that is called what? Internal resistance of that. So practically, what is the Vs? This is the Vs. It has some internal resistance because of the connecting wires, because of this packaging. So this is called internal resistance of the battery. Internal resistance of the battery. So this is a practical voltage source. Now, because of this resistance, this is the resistance because of packaging, because we have to package the battery or connecting wires. So we have some internal resistance. Now here we are connecting the load. Here we are connecting the load. Now guys, what will be the voltage across this VL this time? So first of all, consider the no load condition. Consider the no load condition. Vs. What is the VL? Vs. Why? Because there is no current. This is called no load condition. RL is infinite. IL is 0. So what is the drop across the RS? IL RS is equal to 0. That's why the complete voltage is here across the terminal. So this is the ideal condition. तो नो लोड वोल्टेज इज द Vs. तो आई कैन राइट लाइक दिस, नो लोड voltage is equal to what? Vs under ideal, just like a ideal condition. Now suppose we are increasing the RL. Suppose we are increasing the RL. No load voltage is Vs. Now I am going to increase the RL. Oh, sorry, not increase, decrease. I am decreasing the RL. Then current will increase. This is the current. So RL decreases, current increases, drop across RS increases, IL RS increases, right? So what about the voltage VL? So VL is nothing but IL into RL, or what is the IL? Vs upon RS plus RL into RL. So when IL will, when the RL increases, remember, when the RL decreases, current increases, IL-RS, the drop across the RS will increase. Therefore, the voltage across this will start decreasing. Okay, so that is called what? Loading effect. This word is called loading effect. And now VL is less than what? Vs. VL is less than Vs. So this is the practical situation. So which one is the villain here? Tell me. Which one is the villain? In every movie, in everything, there are two things. One is hero, one is villain. So in that case, which one is the villain? Because of which element load voltage decreases? So load voltage decreases due to what? RS. Yes. बिल्कुल सही बोला आपने आनंद. RS. तो what is our duty as an engineer? Because you are going to become an ISRO scientist. तो आपकी ड्यूटी क्या है? You have to reduce the RS. So you have to use what? Proper packaging material for battery. Suppose I am using a Duracell. ये देखो रखा है. ये रखा ही हुआ यार. Is it visible to you, everyone? Duracell. Right, no doubt we have the different batteries from the different companies, Duracell or what Panasonic or what Nippon and so on. But the cost of this is just double. Why? Because what about the packaging material? Because of that packaging material, what about the internal resistance of that battery? Very, very low. Okay, so last long hai ye, because of very, very small things. Internal losses are very, very less. So packaging material, connecting wires, if you are going to use the connecting wires, that should has what? Same smaller resistance. So tell me guys, I have two chargers, one the branded chargers or one is non-branded charger, mobile charger. So in which case the length of wire is less? Tell me. दो चार्जर है, एक ब्रांडेड है, एक नॉन ब्रांडेड है. तो किसमें आपको वायर की साइज छोटी दिखाई देती है, कम होती है, लेंथ इज लेस. तो आप देखोगे ना ब्रांडेड जो है ना, उसकी वायर की साइज क्या होती है बताओ? कम होगी. ब्रांडेड जैसे लोगे तो आप वायर की साइज ना ऐसा दिखाई देगी आपको, छोटी सी. 1 minute. और इसको ये राइट, और थोड़ी मोटी भी होगी वायर, तो विड्थ इज हाई. और जो नॉन ब्रांडेड है वो, आप क्या बोलोगे? दैट यार कंपनी क्या है, इतना पैसा ले रही है और बड़ी कंजूस है, इतनी सी वायर दे दी है, और इतना दे नहीं सकते थे, लंबा लंबा वायर दे दो. ओके, अरे भाई रेजिस्टेंस क्या होता है? व्हाट इज द रेजिस्टेंस? रो L by A. More will be the length, more will be the resistance or more will be the area, less will be the resistance, and that's why the cross sectional area is high. The cross sectional area is high and length is low, so that the resistance for this is very very less as compared to R2, because the area is less, length is high. So that's this one is preferable. This one is preferable. Okay, this is clear to you, because it will increase the internal resistance of the battery. Okay then. Now we want, ideally the value of the RS should be equal to 0. Practically it should be very 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 less. Now tell me this word again, very very less I am talking. So tell me, when I am saying that RS is 100 ohm, it is a smaller value or bigger value? It should be very very less. Now for particular battery RS is 100 ohm. Tell me, it is a bigger value or smaller value? यहाँ तक क्लियर है? Ideally RS होना चाहिए 0, क्योंकि because of the RS, when we are decreasing the RL, current increases, drop across the RS increases, that's why the output voltage decreases. So ideally RS should be 0. Practically it should be very less. Practically it should be very less. So when I am saying that it is 100 ohm, compare with what? Compare with the load resistance we can determine. बिल्कुल यही चाहिए, and that is the question in what interview? Sobna. So RS should be low. So what is low? We can't say this is a low value or high value. So when the RL, for example, in this particular case, when I am saying that this is the RL, this is the RS, 100 ohm. RS is fixed at 100 ohm. Fixed. One user is using the RL 10 kilo ohm. Okay, it will satisfy the condition very very less as compared to RL, and the circuit will work properly. Circuit will work properly, because we can neglect RS in comparison to what RL, and what will be the output voltage? Vs RS plus RL into RL. So we can neglect the RS. RS is neglected. RL cancel, nearly equal to what? Vs. Nearly equal to what? Vs. In here, this is the first case. What is the second case? If let the RL is 100 ohm, only 100 ohm, so that is not less. It is not a smaller one. It is equal to the RL. Then what is the effect of RS? Watch this. This is equivalent to RL is equivalent to what? RS upon RS plus RS. So what is the load voltage? Just half of the what source voltage. Half हो गया पूरा, आधा आधा distribute हो गया. Half here, because both are equal. So we can't say this is the lower value. It should be less than. In that case, what should be the lower value of RS? It should be equal to what? 10 ohm or 1 ohm. Negligible. Okay. So this is the case. It depends upon the RL. Comparative term hai, RS should be. So always remember, in interview, if they will ask what should be the ideal value of the RS, 0. What is the practical value of RS? It should be very very less as compared to RL. Always say like this. RS should be very very less as compared to RL. Okay. Now up to this point, any doubt? So practical voltage source, ideal voltage source. Now what is the graph for practical voltage source? Graph for practical voltage source. अरे यस और नो लिखो भाई. आई एम नॉट, मैं आई कांटेक्ट तो है नहीं, या फिर वीडियो चालू करना है क्या? अप टू दिस पॉइंट एनी डाउट? बी अलर्ट. ठीक. अरे इतना आप बोलोगे सर इतना छोटे से बात इतना डिटेल क्यों ले रहे हो? इंटरव्यू में कभी भी याद रखना, फॉर इंटरव्यू फॉर इसरो, बार्क, डीआरडीओ and in IITs for MTech program, they will ask what basic questions and then they will start, right? और धीरे 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 slowly they will enter into the depth of that. तो पूरा बहुत ही आराम से पूछेगा. पता चला वोल्टेज सोर्स का सही से जवाब नहीं दे रहे हो, आपने बोला सर स्लो लो होना चाहिए, तो गया क्वेश्चन खत्म. आप जब बोलते हो ना आर एस शुड बी वेरी वेरी लेस देन आर एल, तो ये होता है कंपेरेटिव टर्म. तो फिर लगता है ओके नाउ यू हैव नॉलेज. ओके बी केयरफुल नाउ. साथ में ना इसरो चल रहा है तो इंटरव्यू भी तैयार करेंगे और रिटर्न भी निकालना है हमें. नाउ तो व्हाट अबाउट द ग्राफ under ideal condition? That is the graph. This is the IL, this is the VL, and VL is equal to what? VS under ideal condition. Here the current is 0, current increases but the voltage will remain constant. Under practical condition, when the current increases, voltage start decreasing. Voltage start decreasing. This drop increases and that's why VL decreases. Yeah, this is the condition. Okay, so there is a one more question asked. तो ये है practical condition. So what is the voltage regulation here? So voltage regulation, this is the case. Now, so this is a graph for practical voltage source decreasing, not constant. So what is the percentage? Sometimes it is asked percentage regulation. This is the question from power electronics, or we can say this is the in electronics, or just we can relate with what network also. So percentage regulation means no load voltage minus full load voltage upon full load voltage into 100%. This is the percentage regulation, guys. Okay, definition: no load voltage minus full load voltage upon full load voltage into 100%. What is this no load voltage means? अभी मैंने आपको बताया no load voltage. No load voltage means when the RL is infinite, current is 0, there is no load, there is no current, no load voltage. Full load voltage means RL is minimum. When the RL is minimum, current is maximum. Maximum. And this is called full load current. Full current, maximum current. So when there is a maximum current, voltage will be minimum. So this is the case. So no load voltage and full load voltage. Now, for example, we can solve one question here. No load voltage and full load voltage. Yes, no load voltage and full load voltage. For example, right, one circuit is given. One voltage source is given. Let this is 10 volt. This RS is given 100 ohm. RL is given, right? RL vary from 100 ohm to what? 10 kilo ohm. This is the value of the RL. RL vary from 100 ohm to 10 kilo ohm and RS is given. Find percentage regulation. Find percentage regulation. Tell me guys, what is the percentage regulation? जल्दी 2 मिनट है आपके पास, because number of students have the idea already. I have given you the formula. Find the no load voltage, then full load voltage. What is the meaning of the full load voltage? RL vary from 100 ohm to 10 kilo ohm and RS is given. Okay, then tell me what is the, this is the VS is given as 10 volt. You have to find the percentage regulation. Formula for the percentage regulation: no load voltage minus full load upon full load into 100%. Or no load voltage is when RL is infinite, IL is 0. A full load means this is the condition. Now tell me, it is a good condition, very good, ideal condition, or worst condition? You are getting the 100%. So Adinath, ideal condition. Achha, okay, Kanchan. It is an ideal condition. Okay, now watch this. Okay, time up. अभी अभी अपना आंसर पोस्ट करो आप यहां पर. इसको मैं स्टॉप कर रहा हूं. 2 मिनट हो गया, बताइए. Now try to understand, for this particular question, percentage regulation, we have idea. No load minus full load upon full load into 100%. So watch this. In this particular case, no load means open the circuit. Always remember, no load means open the circuit. No load means current is 0. So what is the no load voltage? 10 volt. No load voltage is 10 volt. Full load voltage means what is the maximum current? When the maximum current will flow? When the load resistance is minimum. So this is the RL, 100 ohm. This is the value minimum, or this is also 100 ohm RS. And this is the 10 volt. So what is the full load voltage? So what is the full load current? 10 divided by 100 plus 100, that is nothing but 1 divided by 20. This is the full load current. So what is the full load voltage? IFL into RL. So this is the 1 by 20 into 100, that is what, 5 volt. Full load voltage is just 5 volt, half of the supply voltage. Half of the supply voltage. Right? Now we have the full load voltage and half load voltage. So you can put it here in formula. So what is the percentage regulation? No load voltage 10 volt, full load voltage is 5 volt, full load voltage is 5 volt into 100%. So you are getting the answer 100%. You are getting the answer 100%. That is the answer for this particular question. Second question in interview, what about this? Ideal condition or worst condition? So this is, guys, worst condition. So what is the ideal condition? Ideally I want RL will change, but this full voltage will not change. What is the ideal voltage source? For example, if the RS is 0, so what is the full load voltage? Everyone tell me. For example, if the RS is 0 under ideal condition, so what is the full load voltage? It will remain 10 volt. So there should be no voltage fluctuation. There should be no change in the voltage at the load. Load will vary, but the voltage should remain constant. So what is the ideal condition? So ideally, 1 minute, full load voltage should be equal to what? No load voltage. If that will be the case, no load minus no load, so what is the percentage regulation? 0%. 0%, ideal condition. Or practically as low as possible. So that was the worst condition actually. Initially you are getting the 10 volt, but when we are decreasing the load resistance, current increases, voltage decreases, and ultimately it becomes 5 volt. Voltage fluctuation by 100%, and that's why the worst condition. Is it clear? Now this is clear everyone. फिर से comments लिखेंगे yes or no. Is it clear? जो भी रिकॉर्डिंग देख रहा है बाद में देखेगा, मैं आपसे बोलूंगा कि प्लीज ट्राई टू अटेंड व्हाट लाइव क्लासेस. Just in recording you can increase the speed by 1.5 or 2x or 3x or 4x, or you can also decrease the speed. लेकिन live classes यार you can ask your doubts also. मैंने तो आपको बोला. Now next one. This is all about what voltage source. Now if suppose two voltage sources are connected, now first we will discuss what current source, percentage regulation. Current source. Under ideal condition, suppose we are connecting the RL. This is the VL. This is the IS. When RL is 0, VL is also 0. And the current will remain IL. IL will remain IS. IL will remain IS. Okay. When we are increasing the RL, IL RL increases, means VL increases. But what about the current? Current will remain same IS. Current will remain same IS. There is no change in the current. That is called ideal condition. So we are changing the value. This time the value is what? Load voltage. This is called load voltage. And that is the load current IL. Voltage will change, but the current will remain constant, guys. What is the value of this IS? There is no change. Here it is 0. VL increases, but it is an ideal condition. It is an ideal condition. Now, we are varying the RL. This time we are increasing. Initial condition RL is 0. Finally RL we are increasing. That's why the voltage increases. What is the practical current source? It has internal resistance RS parallel. Parallelly we are connecting the RS. This is the IS. No. Here we are connecting the load. Here we are connecting the load, guys. And the voltage here is VS. VL. Load. Now what will happen when it is a short circuit? When it will be the short circuit, for example RL is 0, the complete current will pass through the RL. Yes or no? Tell me, guys. According to current division rule, always current will follow the least resistance path. If it is short circuited, the complete current will pass through the RL. So when it is a short circuited, what is the VL? 0. But what is the IL? IS. And what will be the current through the RS? 0, because it will follow the least current path, least resistance path. So IL is equal to IS, VL is 0. Okay. Now when I am going to increase the RL, voltage will increase. voltage drop across this increase, but current will what? Decreases. Current will decreases. So when we are increasing the RL, current will start decreasing. When RL is equal to RS, when RL is equal to RS, right? IL is equal to IS by 2. For example, if both the resistance are same, for example, this is the RS, this is the RS, this current is divided into two equal parts, half through the RS, half through the RL. This is the worst condition, yes or no? When the RL or RS are equal, that is the case, IS by 2. Or again, when we are decreasing the RL or increasing the RL, or RL become infinite. So when the RL will become infinite, so what will be the current through the RL? Zero. The complete current will pass through the RS. Complete current will pass through the RS. So when we are increasing the RL, voltage across this combination will increase, but the current will decrease. So that is called what? Practical condition. This is the practical condition. So under practical condition, current source has internal resistance. This is the part of the current source because of the packaging, because of the connecting wires. This is the part of the current source, RS. And because of this RS, when VL increases, IL decreases. Ideally, RS should be equal to infinite. Or practically, RS should be very, very, very greater than what? RL. If this resistance is very high as compared to that, that complete current will pass through the RL. We want this current should pass through the RL. So ideal condition and practical condition, it should be very, very high. What about the graph then? Finally, so for practical sources, current sources, under ideal condition, that was the graph. Under practical condition, this is the graph. Okay. When the VL is 0, current is maximum. When the VL increases, current start decreasing. Current start decreasing, guys. Okay. So here RL, because VL is what? IL RL. So RL is also 0. When we are moving from this point to this point, RL increases, VL IL into RL increases. But the current decreases, IL decreases. Okay, this point is also clear. Ideal voltage, so ideal current source, everyone. Ideal current source, it is clear. And ideal and practical current sources. So in a up to 10th class, just what we are saying, ideal current source means RS should be infinite. Ideal voltage source means RS should be equal to 0. But just we are giving like that. But here, actually, what is the meaning? There should be no loading effect. Loading means when we are changing the RL, there should be no change in that. If there is a change, means problem. There is a change means problem. Okay. Which one is realizable? Realizable, practically realizable. In a day-to-day life, we are having which source? No doubt, in network, we are dealing with the current source, we are dealing with the voltage source, but practically, which one is realizable? Voltage source or current source? Which one is practically realizable? कौन सा मिलता है बाहर जाते हो मार्केट में तो क्या खरीद के लाते हो? करंट सोर्स की वोल्टेज सोर्स? वोल्टेज सोर्स. यस, वी आर जस्ट परचेसिंग द बैटरी. ये बैटरी है तो व्हाट इज दिस? वोल्टेज सोर्स. वी आर कनेक्टिंग द वायर 240 वोल्ट वोल्टेज सप्लाई. So voltage is given, but we can produce what? Current. By when we are connecting the resistor, there will be the current, but actually practically realizable is what? Voltage source. But in a network, we are dealing with the voltage source as well as what? Current source. In an analog, I will give you the idea how we are going to convert the voltage source into what? Current source. Okay, by using the operational amplifier, by using the BJT, by using the current mirror circuit, by using the MOSFET, current mirror circuit. तो voltage source is converted into current source. Now guys, तो ये तो हो गया connection. If the two voltage sources are connected in series, watch it carefully. This is the V1, this is the V2. Plus minus plus minus. So this is equivalent to V1 plus V2. This is equivalent to V1 plus V2. If these two are connected like this, polarity same है, plus minus plus minus. When we are moving from this point to this point, we have to add, or otherwise this point to this point, we have to add V1 plus V2. Then right, this is the 10 volt, this is the 5 volt. Tell me guys, what is the value of the VAB? What is the value of the VAB? Watch the, please give me the answer. It is equivalent to that, then what is the answer? Minus 5 volt. Good. This is what? Not 5 volt, minus 5 volt. Actually, watch this question. Actually, the 10 volt is greater than 5 volt, so I have to represent like this. It is equivalent to this. This is the 5 volt. But I have changed the polarity. But when I have changed the polarity means what? It is what? Negative. Right? It is what? Negative. So you can represent it like that. Plus 5 volt or what? If you are going to represent like this, this is 5 minus 10. If you are representing 5 minus 10, it will become 5 volt, or when we are calculating across A and B, it is negative. Minus 5 volt. Watch this. This is the minus 5 volt actually. Am I correct? So thoda sa na please be careful about that sign. The potential at A was high. Yes. तो हाँ मैं पूछ रहा हूँ, is it correct? Yes or no? Tell me. There is a one more chance, guys. What I have not represented the terminal at this point. Yes or no? I have not represented the terminal at this point. Whether it is a or whether it is a B, no idea. So that is again. So when we are solving the question, be careful. Where is the A is given? Where is the B is given? So when we are saying that A, B, and I am asking the A, B symbol is given, representation. Just I have represented this diagram and just I have asked what is the value of the A and B, and that's why. Okay. So suppose it is converted into a single battery, then this type of representation, guys. Okay. So normally what we are doing, if the 10 and minus 5 volt it is given, so normally what we are doing, that is more important. So if it is a higher value, I'm giving you the general formula. This is V1, this is V2. If you are representing in terms of this plus minus, then it will become V1 minus V2. Remember? Then or If suppose you are representing in terms of the second battery, then it will become V2 minus V1. V2 minus V1. Now you have the general formula. Now I am going to use this concept. This is the V1 minus V2. Terminal will remain same, A or B. A or B. I am giving you a minus plus V2 minus. If suppose you are going to represent like this, it will become V2 minus V1. Now when I am putting the value here, watch it carefully, guys. When I am going to put the value, for example, I am giving you the value 10, 5. Okay? Then this will become 10 minus 5, that is what, 5 volt. 10 minus 5, that is what, 5 volt. Now it will become V2 minus V1. What is the V2 minus V1? 5 minus 10, it will become minus 5 volt. This is the value minus 5 volt. Okay. The value is minus 5 volt. Representation is no problem, but I am representing it what, minus 5 volt. So suppose I am going to calculate the VAB in that case. Guys, now like this is a source. Try to understand what I want to say. Suppose you are going to write the KVL, it will become minus VAB. This is the polarity, minus VAB minus VS is equal to 0. So what is the VAB is equal to? VAB is equal to minus VS. Okay. Now tell me, guys, what is the value of the VS? Plus 5 volt or minus 5 volt? Everyone. This is the minus 5. Minus or minus, it will become what? Plus 5. This point is clear, everyone. This point is clear. तो यहां अगर मैंने पोलैरिटी दी होती आपको ए बी, तो व्हाट विल बी द आंसर फॉर VAB? प्लस 5 वोल्ट. Plus 5 volt, because A is at higher potential than B. So what is the general? You can represent like that with V1 minus V2, but V2 minus V1. But here the V2 is less than V1, and that is the case. And that's why again we have used the KVL here. So from both the diagram, value should remain same. From this directly we can send VAB is equal to 5 volt. Suppose that is the representation. Again we want the VAB should remain 5 volt, because in this diagram what is the VAB? 5 volt. All the three diagrams should be equivalent. All the three diagrams should be equivalent. Okay. Okay, Sobna. Try to understand. I have given you the question. What is the value? For example, if suppose you are not going to add or subtract, you are not going to represent it in a single voltage source. Okay. Suppose just you want to represent like that. Calculate the VAB. Calculate the VAB in first case. Because you don't want to represent like this. You don't want to represent like this. Okay. It is not given VAB. This is the higher potential, this is the lower potential, this is the VAB. So write down the KVL. When I am writing the KVL, this is the minus. In next class, I will give you the idea about the KVL and KCL. Right? Complete detail about the KVL and KCL. Don't worry, we will solve number of questions. Just we have the basic idea. This is the minus. We are writing the Kirchhoff's voltage law, minus VAB plus 10. Am I correct? Plus 10 minus 5 is equal to 0. So what is the value of the VAB is equal to 5 volt? Am I correct? This point is clear? Yes? No. We can represent it like this. If you are putting the plus here, minus here, so this first battery has plus here, minus here, plus here. And that's why what is the general representation? V1 minus V2. V1 minus V2, that is nothing but 5 volt. So what is the VAB? Directly you can say the VAB is what? 5 volt. Okay, this is the 5 volt. No problem. Answer is 5 volt. From this figure 5 volt, from that figure 5 volt. Third case is, suppose you want to represent it like this. This is the terminal AB, no problem. But you are giving the polarity. So for this, what is the general formula? V2 minus V1. V2 minus V1. So normally we are using this formula or this polarity when the V2 is greater than V1. When the V2 is greater than V1. But in this case, V2 is less than V1. So what is the V2 minus V1? Minus 5 volt. So actually when this is the, for example, generalized term, it is the VS, it is the VAB. Tell me, minus VAB, this is the minus, this is the minus VS is equal to 0. So what is the VAB? Is equal to minus VS. This is the general answer. Is it clear? General answer, VS. But what is the value of the VS? Minus 5 volt. This is the VS. So minus minus it will become plus 5 volt. Not as clear? Okay. तो इसी में एक और क्वेश्चन बनाते हैं तो और क्लियर हो जाएगा ये. If it is given, this is 5 volt, this is 10 volt. Now, for this case, actually what should be the representation? Like this. It is represented by the single battery with reverse polarity, and what is the value of that? 5 volt. Now in that case you can say what is the VAB? Minus 5 volt. Minus 5 volt. This is the higher volt, this is the lower one. So normal for this case we are representing like that. Okay, but representation तो कुछ भी हो सकता है, उल्टा सीधा कुछ भी कर देगा आपको क्वेश्चन में, आपको बताना है. I think now it is crystal clear, no? One voltage source and one current source is connected in series. So tell me guys, it is equivalent to voltage source or current source? When the one voltage source and current sources are connected in series. So remember, what will be the value of this battery? 5 volt, 10 volt, 20 volt, 30 volt, it doesn't matter. What is the current enter into the load? What will be the current enter into the load? It will remain same 2 ampere. Right? Suppose you are going to change the value 10 volt. Again it will remain 2 ampere. Suppose you are going to change the 20 volt. Again it will remain 2 ampere. Yes? So actually when the voltage source and current source are connected in series, it doesn't matter. Always the current enter into the load is what? 2. So we have to deal with the load only. So what is the current enter? 2 ampere, and that's why it behaves like what? Single current source. Behaves like single current source, guys. It is a current source actually. when one voltage source and current source are connected in series, it is a current source. Then when the current source and one resistors are connected in series, or this is a variable resistor, it will vary. Tell me, it is equivalent to, again it is equivalent to what? Current source. Same logic. In place of this, if you are connecting the resistor, it doesn't matter what is the value of the resistance, what is the current enter into the load, 2 ampere, fixed. 2 ohm resistor, 5 ohm resistor, 10 ohm resistor, it will remain 2 ampere. So simple. So one resistor and one current source is connected in series, then it is a current source. Now variable resistor, it is equivalent to, tell me, it is equivalent to, guys, it is equivalent to what? Voltage source. Yes, because it doesn't matter what is the value of RS. VL parallelly, VL is always 10 volt. This is the load. So load voltage is 10 volt irrespective of the value of the RS, and that's why this is represented by a voltage source. Single voltage source. Okay, this is also clear. Now, so this is a voltage source in a parallel resistor, it will not affect the value of the Vs. Okay, then this was the question in assignment. One voltage source is connected in parallel with what? One current source. This was the question in ISRO examination. Tell me, guys, again same logic. If you are connecting the current source or voltage source, it doesn't matter what is the value of this current source, the load voltage will remain what? 10 volt. Load voltage will remain what? 10 volt, and that's why it is equivalent to a voltage source. Equivalent to what? Voltage source, guys. ये क्वेश्चन था. An ideal constant current source is connected in series with an ideal constant voltage source. Considering both together, the combination will be. Tell me, what is the answer? Ideal constant current source is connected in series within an ideal constant voltage source. Considering both together, the combination will be a constant voltage source, constant current source, constant power source, none of the above. Constant current source, बिल्कुल सही. Series में ना, not in parallel. It is connected in what? Series. So B is the answer for this question. Okay. Now, so this is all about what? Independent sources. These all are independent sources. Now there are dependent sources also. So there are dependent sources. So there are 4 types of dependent sources. Dependent sources means the voltage or current depends upon the branch voltages or what? Branch current. It depends upon some branch voltages or branch current, and these are called dependent sources. तो there are four: voltage control voltage source, current controlled current source, voltage controlled current source, current controlled current source. There are four types of dependent sources. So in network, normally we are representing, this is the symbol for that. For dependent sources, this is the dependent sources. So these are the dependent sources. Now representation is like this. If this is the case, Vs is equal to alpha V, so this is a voltage controlled voltage source. This is called voltage controlled voltage source. So you can find the value unit of the alpha. Alpha is equal to Vs upon V. V is the branch voltage or voltage across any particular element. So Vs depends upon that V. So it is a unitless. It is a unitless. Alpha is unitless because voltage control voltage source. Voltage control voltage source. Second is, for example, this Vs is equal to alpha I. This Vs is equal to what? Alpha I. So this is a voltage source, but it depends upon the current. That's why it's called current controlled voltage source. And what is the unit of alpha then? Vs upon I, ohm. Here the unit of constant term is what? Ohm. So resistance multiplied with the current, this will give you the voltage source. Right? So this is a ohm. So this is a voltage source. This is also a voltage source, current control, voltage control. Current control, and one is voltage control. Then all the rule will remain same. Don't worry about the rules. All the rules will remain same. Series connection, parallel connection. But here, if this is given alpha I, so this is the Is, that is equal to alpha I. So it is a current controlled current source. Current controlled current source. So what is the value of the alpha? Is upon I, that is unitless. Unitless quantity. This is the current controlled current source. And finally, alpha V. This is the Is is equal to alpha V. So it is a voltage controlled current source. And what is the unit of alpha? Is upon V. This is nothing but mho or Siemens. Mho or Siemens. It is a conductance. The voltage control, current control voltage source. Right? So these are the symbols, guys. 1, 2, 3, 4. So analog, we will deal with what? 4 types of amplifier. Right? Analog, we will deal with the 4 types of amplifier. Voltage amplifier, current amplifier, trans conductance amplifier, and what? Trans resistance amplifier. So when we are dealing with the equivalent circuit of those amplifier, so we are using these dependent sources. This is the voltage amplifier. Right? Current control voltage source. So current is converted into voltage. So trans resistance. Voltage controlled current source, voltage is converted into current, to trans conductance, or current is converted into current. So this is what? Current amplifier. So there are 4 types of amplifier, and that's why we have 4 types of what? Dependent sources. Are you getting my point, everyone? अरे 4 का बहुत बड़ा रोल है. 4, नंबर 4 is very very important. कितने वो हैं बताओ आप जरा, कितनी दिशाएं हैं? 4, नॉर्थ साउथ ईस्ट वेस्ट. राइट? नॉर्मली इस कमरे में कितने कॉर्नर्स होते हैं? हाउ मेनी कॉर्नर्स इन अ रूम? नॉर्मली जो ब्यूटीफुल लगता है, जो एस्थेटिक है, तो आप देखोगे हर में कितने कॉर्नर्स हैं? 4 कॉर्नर्स है. तो 4 is a very very important number in what? Electronics. In number, in 4 types of amplifier, 4 types of dependent sources, and so on. So you can also give me the example, 1 or 2 example from day to day life, how the number 4 is important. Okay, so there are 4. So series connection, parallel connection will remain same, no problem. ठीक है, series connection and parallel connection will remain same. Last theory part, then we will solve numericals, guys. Source transformation. सोर्स ट्रांसफॉर्मेशन। अरे जागते रहो भाई, जाग रहे हो यहां पर, यस और नो एक बार फिर से लिखो। अप टू दिस पॉइंट एवरीथिंग इज क्लियर। मुझे भी तो मोटिवेशन होना चाहिए ना। अच्छा बताओ, एकदम ईमानदारी से बताना, कहां हो अभी आप लोग? ऑन टेबल, चेयर, और ऑन सोफा, और ऑन बेड? किसमें हो भाई? एकदम सही जवाब देना है ना, जो इधर उधर कोई नहीं बोलेगा। और अदर देन दैट, टेबल, चेयर, सोफा, बेड, ऑफिस, कार, राइट? पक्का? ये देखो, ये आया ना शोभना मैडम, शोभना जी, ठीक है। सो ये होती है ईमानदारी। तो ठीक है, कम से कम जवाब तो दे रहे हो कि कहां पर बैठे हो। भाई मुझे नहीं है, आई एम नॉट हैविंग द फ्रीडम कि मतलब मैं कहीं से भी पढ़ा लूं। मुझे यहाँ पे आना होगा। ये मेरे घर से, दिस इज अ 1 किलोमीटर अवे फ्रॉम माई हाउस। दिस इज द स्टूडियो, राइट? तो फर्स्ट ऑफ ऑल आई हैव टू वेक अप एट द 5. तो normally I am used to wake up at what 6 or 6:30, but now these days 5 a.m. and then within 1 hour, then I have to ready to take what classes. But this will take time because I have to start the smart board, laptop, camera, setup, lights. So it will take around 15 to 20 minutes, and then I have to start what the Zoom classes. तो आप लोग कोई गेम्स खेलते हो, क्रिकेट वगैरह? क्रिकेट, बैडमिंटन, चेस, जो भी। तो मुझे थोड़ा सा क्रिकेट खेलने का शौक है। तो कल मैंने अपने हाथ भी, मेरे को पूरा फ्रैक्चर है कि पता नहीं, अभी मुझे चेक करवाना पड़ेगा। लेकिन चलो, लेफ्ट हैंड में प्रॉब्लम हुई है, बॉल लग गई यार, बताओ। और वो तो हुआ ही हुआ, घर में अलग डांट खा रहे हैं कि अपनी एज का तो ख्याल रखो। अब बताओ, कहीं से भी लग रहा हूं मैं तो बच्चे ही लग रहा हूं आप लोगों तो, मतलब मुझे तो अपनी एज ही समझ नहीं आती। रीजन भी है उसका कि मुझे फील नहीं हो रही है कि मेरी उम्र बढ़ रही है। क्यों नहीं हो रही है बताओ आप जरा। मैं ना हमेशा डील करता हूं, ऑल द टीचर्स आर नॉर्मली डीलिंग विद व्हाट, 18 years, 19 years, 20 years, 21 years, 22 years, अप टू 30, मैक्सिमम अप टू व्हाट 30। और एक्टिवली वर्क कर रहे हैं और इंजॉय कर रहे हैं। एक्चुअली काम तो कर रहे हैं, लेकिन काम को क्या कर रहे हैं, इंजॉय कर रहे हैं। तो जब इंजॉय कर रहे हो, लगता ही नहीं काम कर रहे हो। पढ़ाने के लिए अभी बोल दिया जाए ना 10 hours, तो पढ़ा रहे हो बिंदास सुबह से लेकर शाम तक। और इसीलिए मैंने आई हैव रिजाइन। तो सम स्टूडेंट आस्क, सर सपोज दैट जॉब इज सो lucrative for engineering services examination, you was the class 1 officer, you have cleared the engineering services exam multiple times, then why you have left that job? Because that is the lucrative job, powerful job, but I'm fond of what teaching, तो ये मुझे पसंद है। तो इसीलिए वर्किंग कर, एज ही नहीं बढ़ेगी। और सबसे क्या, यंग माइंड से आप डील करते रहते हो हमेशा, जो इनोसेंट है, फ्रॉम 16 years old to what up to what 30 years। इनोसेंट का मतलब समझ रहे हो मैं व्हाट आई वांट टू से? आदमी ना बदमाश तब होता है जब वो जॉब में जाता है, तो पूरी दुनियादारी सीख जाता है। और जब तक पढ़ रहा है तो ध्यान रखना, वेदर इट इज इसरो एग्जाम, DRDO, UPSC और अदर कॉम्पिटिटिव एग्जाम्स, ऑलमोस्ट फेयर है, ऑलमोस्ट फेयर है। एक आध % कुछ धांधली है वो अलग बात है, लेकिन मतलब फेयर है। तभी तो आप ड्रीम कर पा रहे हो ना कि मैं एग्जाम निकालूंगा। For example, UPSC, I have cleared 4 times. Every time I got the number according to my performance, right? Whether it is an interview or written or what objective. अगर फेयर नहीं होता तो मैं 4 बार कैसे निकालता? तो इसीलिए आपका इसरो का भी एग्जाम ऑलमोस्ट फेयर होगा, आपका जो भी DRDO देंगे वो भी। अगर आप किसी कारण से सेलेक्ट नहीं हो पा रहे हो तो ब्लेम मत करो, चेक करो कि प्रॉब्लम कहां है। कभी कभार हो जाता है, इंटरव्यू अच्छा चला गया, कोई बायस्ड हो गया और इंटरव्यू में कम ज्यादा मार्क्स आ गए, लेकिन बोला ना मैंने 99% सही है, 1% तो अब कुछ बोला नहीं जा सकता, इट्स डिपेंड्स। तो ये होप ये आपको बात मोटिवेट करेगी। अगर आपका कहीं सिलेक्शन नहीं हो रहा है, मींस कुछ प्रॉब्लम है, उसको शॉर्ट आउट करो, उसको डिस्कस करो। आप मुझसे भी डिस्कस कर सकते हो कि सर I'm not comfortable with this subject, or I am facing problem with what interview and so on, how to give the interview and so on. Okay, so don't worry about that. कई बच्चों को इंग्लिश का डर होता है, तो इंग्लिश तो अपनी भी ठीक ठीक ही है, जितनी आती है उतनी है, टेक्निकल के लिए ठीक है, बहुत ज्यादा मैं न्यूज में जाके बोलोगे कि न्यूज पढ़ लो या डील कर लो तो उतनी नहीं है हमारी, लेकिन चलेगा. ओके, तो आर यू गेटिंग माई पॉइंट? ऑल आर कंफर्टेबल विद माई इंग्लिश, यस और नो? तो I can explain all this. So in technical interview, they will ask technical question. So don't worry about the English also. If you are not comfortable with English, okay, try to explain all the technical terms. Okay, more than sufficient. Just in ISRO, sufficient. In GATE, sufficient. In engineering services, sufficient. Okay. Now, source transformation. Source transformation means we can convert the voltage source into current source, or current source into what? Voltage source. The source transformation, watch this. If it is given a current source, you can convert it into voltage source. What is the value of the Vs? This is Is into Rs. Always remember the polarity. Polarity means this is the direction, this is the in above, this will become plus, this will become minus. So that is the plus and minus, and Rs in series, same resistor. Suppose it is of 5 ohm, the same resistor 5 ohm. If it is of 2 ampere, then it will become 2 into 5, 10 volt. 10 volt. This is the 10 volt, and this will remain same 5 ohm. So current source is converted into a voltage source. Then similarly, voltage source, if it is given, you can convert it into a current source. If it is given 10 volt and this polarity, always remember polarity. The current will move from minus to plus. Current will move from minus to plus. And the resistor is connected in parallel, guys. So what is the value of the current? Vs upon Rs. 10 upon 5, that is the 2 ampere. This is of 2 ampere and this is of 5 ohm. The resistor will remain same, but it is connected in parallel, and this is the 2 ampere. So voltage source is converted into a current source. Voltage source is converted into a current source. Be careful about the polarity. If this is the polarity is given, so it is a downward, the current direction of the current downward. This will be the direction. The value will remain same. The value will remain same, but the direction, according to polarity, you have to change the direction. This is the minus to plus. Current will move from minus to plus. Minus to plus. Okay. Or voltage polarity, this is the plus, this is the minus. If this is the case, suppose we want to convert this, and remember, polarity, this is the arrow, this is minus, this is plus, this is minus, this is plus, Vs. Is into Rs. Okay. So this is called a source transformation, voltage to current source, current to voltage source. And Rs is the internal resistance of the current source. Ideal value is infinite, practical value is 0. Rs is the internal resistance of voltage source. I think now all are ready to solve some questions. Okay, then try to solve this question. Use the source transformation to find V0 in the circuit. बस आज हम लोग source transformation पर बनाएंगे. Tomorrow we will discuss KCL, KVL and so on. Tell me what is the answer. Don't use the nodal analysis or mesh analysis, simply by using the source transformation. just to practice the source transformation. So what is the value of the V naught? With the help of the source transformation means you can convert this voltage current source into voltage. What the polarity? This is the arrow. So this is minus, this is plus. So 3 into 4, 12. Polarity. Be careful about the polarity. This resistor is in series. This resistor is in series. Suppose you want to find the voltage, then don't change the 8 ohm resistor. Or you can convert it into a voltage source. Suppose you want to convert, then yes, this is converted into a current source. 12 divided by 3. This is 3 ohm and this is what? 4. If you want to convert, otherwise no need. 12 divided by 3, that is the 4 ampere. Twelve divided by 3, 4 and 3 ohm in parallel. So this is the 4 ohm, this is the 2 ohm. Now this 4 and 2 is in what? 6. Now 12 divided by 6, you can also convert it into what? Single current source. 12 divided by 6, 2 ampere. In a parallel 6 ohm, 8 ohm, 6 ohm, 8 ohm, this is the 8 ohm and this is the 3, and this is what? 4 ampere. This is the 4 ampere. Now what is this diagram, guys? This 4 ampere and this 2 ampere are in parallel. So when the 4 ampere and 2 ampere are in parallel, we can add them. Suppose I am going to add them. So this is the 4, this is the 2, total is what? 6 ampere. 6 ampere. Now what is the parallel combination of 6 and 3? You can't change this voltage because we have to find the voltage across that. What is the parallel combination of 6 and 3? Tell me. 2 ohm. Parallel combination of 6 and 3 is 2 ohm and this is what? 8 ohm. 2 ohm and what? 8 ohm. Okay. Now there are various ways to solve the questions, how we can find the V naught. What is the, if suppose you want to find the voltage across that. Voltage across that. Are you giving the answer to 12 volt everyone? You are getting the 12 volt. Is there any calculation mistake? चलो देखते हैं. Right? Suppose you want to find the voltage across what? 8 ohm resistor. So these two are in parallel in this way, or you can again convert this into what? Voltage source. 6 into 2, that is what? 12 volt in a series with what? 8. तो चलिए लास्ट में मैं देखता हूँ जरा क्या बोल रहा हूँ आप लोग. आंसर चेक करो, आपका आंसर सही है, यस और नो? ओके. So what is the voltage V naught is equal to 12 divided by 2 plus 8 into 8. So what is the answer here? 1.2 into 8 but 9.6 volt आ रहा है आंसर. तो am I wrong? आज मेरे से भी हो सकती गलती. I am getting the 9.6 volt and you are getting what? 12 volt. क्यों भाई? श्रमिक, हर्षिता, you are giving the 1.3 volt. Priyasa, tell me, this is right, this calculation is right or wrong? Tell me everyone. This calculation is correct. This is 3, this is 4. I have converted into. अब problem कहाँ है? पता है कहाँ problem है? Where is the problem? Tell me. There is the problem, guys. When I have to convert this 12 volt into what a current source, what should be the polarity? It should be downward. What should be the polarity? It should be downward. First mistake. Are you getting my point, everyone? When I have to convert this 12 volt battery into a current source, there is a wrong. Polarity is wrong. Downward direction. First condition. Because from this is negative to what? Positive. Second. Now, if this is the case, then 4 and 2 in parallel, then it will become what? 4 minus 2, that is the 2 ampere. This is the another mistake. So there is a one mistake, and because of that, 2 ampere. Now, if it is a 2 ampere, then this is the 2 ampere. This 2 ampere multiplied with the 2, this is not the 12, this is the 4. 4 volt. Now, so what will be the answer here? 4 divided by 8 plus 2 into 8. 3.2 volt. क्या हुआ? कोई बोल ही नहीं रहे तो इजी क्वेश्चन है. यस, आर यू सौमिक, योर आंसर इज करेक्ट? यस और नो? I have just asked what is the value of the V naught. This answer is correct, yes or no? मुझे बताओ confidence के साथ में. Harshita, how you are getting the 1 point? I have the different method to solve this question, but just I want to check my calculation. तो देखो मैंने क्या किया बता देता हूँ आपको, फिर से देखो रिपीट कर लेते हैं. First of all, I have converted this to 3 into 4, that is the 12 volt. This 4 and this 2 are in series, so this will become 6 ohm. Right here I have converted the 12 divided by 3, 4 ampere and 3 ohm in parallel. Then I have again converted this voltage source into current source. 12 divided by 6, that is the 2 ampere in downward direction. This is in upward direction. Now this resistor, it is in parallel because it is converted into a current source. Then the parallel combination of 6 and 3 is what? 2 ohm. This is the 8 where I want the V naught. 4 minus 2, it is a 2. Now I want the 8 ohm, then 2 into 2, that is the 4. Okay. 4 volt, 2 ohm, 8, it is connected in series. Now voltage division rule, or we can say what is the current? 4 divided by 2 plus 8 into 8, that is the 3.2 volt. चलो, अब आपको लगता है सर गलत भी तो हो सकता है. कोई बहुत से मेथड होते हैं क्वेश्चन को सॉल्व करने के, कोई जरूरी नहीं है कि आप इससे ही सॉल्व कर रहे हैं. देखो जरा, आपने सोचा कि सर मुझे इसको चेंज नहीं करना है, तो आप इसको बस चेंज कर लो और आप वोल्टेज फाइंड कर सकते हो. बस ये आपने यहां से चेंज कर लिया, 3 इंटू दैट इज द 12, तो भी आप बना लोगे. आपने जैसे भी चेंज किया नो प्रॉब्लम, लेकिन बस इसका थोड़ा सा ध्यान रखना. 3 इंटू 4, 12 volt. 4 and 2 are in series, 6. This is the 8. Right? We have to find the V naught. तो नॉर्मली हम लोग क्या करते हैं, नोडल जो एनालिसिस होती है, वी हैव टू फाइंड द V naught. तो नोडल एनालिसिस में हम लोग क्या करते हैं, ये बैटरी बन गई, दिस इज कन्वर्टेड इनटू अ करंट सोर्स, दिस इज द वोल्टेज इज V naught. तो वी आर राइटिंग V naught माइनस ऑफ -12. हम लोग जस्ट प्रैक्टिस कर रहे हैं ना. V naught माइनस ऑफ -12 अपॉन व्हाट 6 प्लस V naught अपॉन 8. This is the V naught minus 0 by 8. This is the ground. We are taking the reference. This is called nodal voltage. So just what we are doing, actually we are calculating the current in this branch. And the sum of the current is equal to what? 0. So which law? Tell me guys. Sum of the current is equal to what? 0. So VA minus of -12 by 6. This is the first current. Second current is V naught minus 0 by 8. Third current is V naught minus 12 divided by what? 3. 12 divided by what? 3. Then you can take the LCM. What is the LCM? 24. because 24 is divisible. 6 4 V naught minus minus plus, this is 4 48 plus 3 V naught plus 8 V naught minus 96 is equal to what? 0. This will become 0, and then 4 plus 3 plus 8, 7 plus 8, 15 V naught is equal to 96 minus 48, 48. So what is the V naught? Is equal to 48 divided by 15. Same answer, 3.2 volt. Are you getting my I am getting the same answer, yes or no? तो यार कोई जवाब ही नहीं दे रहे, क्या हो गया, गायब हो गए? ओके, तो कहां मिस्टेक है? व्हाई यू आर गिविंग द 12 वोल्ट? तो प्लीज चेक इट. ओके, so this is called what? KCL. Tomorrow we will discuss that, but it is called what? Kirchhoff's current law. Current from this point, this point, this point, the sum of the current leaving a particular node or entering into the particular node is equal to what? 0. So I1 is leaving, I2 is leaving, I3 is leaving. So I have done I1 plus I2 plus I3 is equal to 0. That node voltage is V0. So what is the current in this branch? V0 minus of minus that, V0 minus of that, and so on. V0 minus 0. So this type of analysis is called what? Nodal analysis. So that in again in further chapter we will discuss what? Nodal analysis and mesh analysis. So super nodal, mesh, super mesh. So a particular numerical we can solve by the different methods. So I have used the source transformation plus nodal analysis. Here I have used only the source transformation. I have used the source transformation. Okay. So be careful now. This is the question, guys. Six ohm, 5 ampere, 3 ohm plus 5 volt battery is connected here. 7 ohm. We have to find the I naught here. This is the 3 ampere. These two are in series. Then find the I naught through the 7 ohm resistor. तो गाइस चलो आप भी सॉल्व करो, मैं भी सॉल्व करता हूं, देखते हैं क्या है. First of all, remember this 3 and this 6 are in parallel. So this is converted into a single resistor, 2 ohm. 6 and 3 are in parallel. Then 2 ohm is connected parallel to the 5 ampere. So 5 into 2, that is that it will convert it into a 10 volt battery. 6 and 3 are in parallel, 2 ohm, 2 multiplied with the 5, 10 volt battery, 2 ohm resistor in series. This is clear. Voltage source converted into a voltage source. There is another voltage source, 5 volt, in a series with that. Then we have to find the current. So don't change the resistor, 7 ohm. Then 4 and 1 are in what series? So this has become 5 multiplied with the 3, 15. 15 volt, and this is 4 plus 1, 5 ohm. This is converted into a voltage source. Now these two voltage source are in a series, plus minus, and that's why it will become what? 15 volt. That's why it will become 15 volt, 5 plus and 2 ohm in series. So this is the 15 volt battery. This is in series, 7 ohm, 15 and 5. So this is also the 15 volt, this is also the 15 volt. But what is the value of the resistor? 5 ohm. What is the value of this resistor? 2 ohm. And what is the value of this resistor? 7 ohm. Now, can you apply the nodal analysis, or we have to find the current here? We have to find the current here, I naught. Okay. To find the current, first find the V naught. Then you can find the V naught by 7. This is the current. Write down the nodal V naught minus 15 divided by 2. V naught by 7. V naught minus 15 divided by 5. Tell me guys, what is the LCM here? Because it's not divisible, so 7 into 5, 35, 70. So it will become 35 V naught minus 15 into what? 35. You can use your calculator also. लेकिन याद रखना इसमें calculator नहीं हो, बहुत lengthy question थे. Last time that was the calculation was very lengthy. So avoid the calculator, solve. This is what 525 plus 10 V naught plus 14 V naught minus 210 is equal to 0. तो ये 0 हो गया. 35 plus 10, 45, 55 V naught is equal to 5 2 7 735. So what is the V naught is equal to 735 divided by 55. 735 divided by 55. 13.36. 735 divided by 55, and now it is divided by what? 7 ohm, because the current is required. Because the current is required, (21 by 11) 1.91. 1.91 I am getting. 1.91. 1.91. How the resistor and 5 volt interchange position. Okay. Acha, okay. Tell me. So always remember. So finally the answer is this is my answer. Check your answer. If there is a silly mistake, then please inform me. Okay, you have said that, sir, these are connected in series. Why you? How we can change the position? Yes, this is the question. Sir, it's where is the mistake? 59 V naught. Oh, where is the 59? 35 plus. अरे भाई साहब, सही में ना. Sorry भाई, sorry. 35 plus 14. 49 or 1059. Silly mistake. Everything is fine now. 735 divided by 59. This is the value of the V naught. And then 1.779. Not is correct. या मेरे पास ना आंसर नहीं है, जस्ट कैलकुलेशन है ना. V naught by 7 in the equation is negative. Why negative? No. This is correct. V naught by 7 is positive. V naught minus 15 by 2 is also positive. V naught minus 15 by that is correct. No problem. Why? Because we are calculating the outgoing current. What is the outgoing current? V naught minus 15. What is the outgoing current? V naught minus 0. What is the outgoing current? V naught minus 15 by 5. This is correct. There is no problem. Okay. Calculation is your part. Now, one student asked, sir, how the register we can check it. Otherwise, you will get the answer for this. Then, remember, one student asked, sir, how you can change this register position. Suppose one battery and one resistor is connected here. Okay. Now, what is the no load voltage? 10 volt. RS or 10 volt are in series. You can change the position also. Because these are connected in series, what is the voltage at this point? It will remain 10 volt. Tell me, both are correct? We are changing the position of what? Resistor. So in a series, if any elements are connected in series, we can change the position. It doesn't matter. Resistor, inductor, capacitor are connected. We are just changing the position from this point to this point, that point to this point. The value will remain same. The result will remain same. Okay. This is clear. So what I have done, just I have changed 2 ohm here. So just I have changed the 2 ohm and 5 position of the 2 ohm and 5 volt. No problem. Now I have changed this 5 volt and 10 volt are in series. That will become 15 volt. This will become 15 volt. ठीक है. तो आंसर यार करेक्ट है. यस और नो चेक कर लेना. कुछ गलती होगी तो बता देना. वैसे कैलकुलेशन कर लोगे. दिस इज अ कैलकुलेशन इज योर पार्ट. But I have given you the idea how to solve this question. I think no other concepts. Everything is fine. How we can change the current source into voltage source. Then at the end, I have applied what? Nodal analysis. Outgoing current. This is the outgoing current. This is the outgoing current. That is the outgoing current, and that's why this is the case. Polarity is perfect. No problem. So guys, this is a homework for you. What you have, find the Vx in the given electrical network shown in the figure using the source transformation. You have to find the Vx. This is the dependent source. Okay, I will solve this and then I will give you the assignments. If there is a dependent sources also, dependent sources. This is a dependent sources. If there is a dependent sources, again you can apply what? Source transformation. So what we have to do? We have to find the Vx. This is the dependent sources. It is a voltage controlled current source. This is voltage, but it is a current source. So it is a voltage controlled current source. And this Vx is the voltage across the 2 ohm resistor, guys. Vx is the voltage across the 2 ohm resistor. We have to find the Vx. When we have to find the Vx, so what you can do? You can apply the source transformation here. So this 0.25 Vx is multiplied with the 4 ohm. So 0.25 Vx multiplied with the 4 ohm. So you can convert it into a current source. Current source is converted into a voltage source. So watch this. So current source is converted into a voltage source means 6 volt. This is 2. This is 2 ohm. Now this is a 2.25 multiplied with the 4, it will become a Vx. Polarity. This is plus, always remember this is plus, this is minus. From towards the, always remember the polarity, otherwise you will do the silly mistake. 0.25 into 4, it is 1 Vx. This is the 4 ohm resistor in series. And there is a one battery 18 volt. And this is the Vx. This is the value is what? Vx. That is the case. And this is 2 ohm. This is the source transformation. Now after source transformation, once you have this diagram, these two are converted into a single battery. What is the single battery? 18 plus Vx. This is the plus minus, this is the plus minus. So 18 plus Vx. The total is 18 plus Vx. This and that. So you can apply the nodal analysis again to Vx minus 6 by 2. Vx minus 6 by 2. Vx minus 0. This is the reference to Vx minus 0 by 2. Again outgoing current. Vx minus 18 minus Vx. Vx minus of minus, this is what 18 plus Vx, sorry. This is the 18 plus Vx. This voltage minus this combined voltage, Vx plus 18 upon 4 is equal to 0. Now, this Vx is cancel out. So, you can write like that, or you can take the 4 as a LCM. So, it will become 2Vx minus 12. This is plus 2Vx. This Vx is cancel out, so no need to calculate. This is the minus 18 to minus 18 is equal to 0. This 4 will become 0. 2 to 4 Vx is equal to 30. by 4, 7.5. This calculation is clear to you, everyone? Calculate. If there is a calculation mistake on that, okay, you can inform me. Otherwise that is clear to you. First of all, you can also convert the dependent sources into you can also apply the source transformation in dependent sources. This current source in a parallel with the 4 ohm resistor, this is the terminal A, this is the terminal B. Then you can convert it into a voltage source 0.25 Vx multiplied with the 4, that will become Vx, and this is the 4 ohm in series. So this is the terminal A, this is the terminal B. It is converted. Polarity, this is plus, this is minus, this is plus, this is minus, 4 ohm resistor. Now the Vx and 18 volt are in series, so total will become 18 plus Vx. And now apply the nodal analysis. Vx minus 6 outgoing current. There are 3 outgoing currents. Sum of the outgoing current is 0. This is the I1, this is the I2, this is the I3. This is called KCL. This is the I1. What is I1? Vx minus 6 by 2. I2 Vx minus 0 by 2. I3 Vx minus that by 4 and is equal to what? 0. And that is the case. Take the LCM. 2Vx minus 12. 2Vx. Because this Vx and this Vx is cancel out. No need to consider it. Minus 18 and then this is 0. Okay. Clear point? तो आप आंसर वेरीफाई कर लीजिएगा. That is the case. तो easy है guys. So now it is time for assignment. Are you ready to solve some questions? देखो first assignment. Okay. Yesterday I have given some assignments. We will solve. Don't worry about that. In weekend we will solve. So first try to solve this question. You can use the source transformation or you can use the direct nodal analysis. It's up to you. But try to solve this question. I need correct answer, guys. Because when we have to solve the Thevenin's theorem, Norton's theorem, or what superposition theorem, or when we have to solve the question from the transient, these are the calculation. तो ये कैलकुलेशन में आपकी मास्टरी हो जाएगी, तभी आप उसमें आराम से बना पाओगे. अगर आपने यहाँ पे इसमें कमांड नहीं की कि कैसे चेंज करते हैं, ये नहीं आएगा स्ट्रेट फॉरवर्ड. लेकिन आपका थेवेनिन्स थ्योरम, नॉर्टन्स थ्योरम या एनालॉग में या दूसरे सब्जेक्ट में सब कॉन्सेप्ट यूज होंगे. इसलिए भाई कमांड करो. ये 24 मिली एम्पियर करंट सोर्स दिया हुआ है, तो आपको आंसर निकालना है. ठीक है. ऐसे भी है इजी से क्वेश्चन, बहुत सिंपल सा क्वेश्चन है ये. शायद आई थिंक इसरो का ही क्वेश्चन है ये. चेक कर लेना. कल हम लोग 2-3 चीजें और करेंगे. देखो क्वेश्चन सॉल्व करेंगे, जो आपको असाइनमेंट दिया वो भी देख लेंगे, और केसीएल एंड केवीएल. केसीएल एंड केवीएल समझने के बाद वी हैव टू सॉल्व द नंबर ऑफ क्वेश्चंस गाइस. ओके. तो जितना भी मैंने आपको असाइनमेंट दिया है वो भी सॉल्व करना है. और कल का एजेंडा है, प्लीज डोंट मिस द क्लास. ट्राई टू अटेंड द लाइव क्लासेस. वोल्टेज डिवीजन एंड करंट डिवीजन. right? And then Kirchhoff's current law, Kirchhoff's voltage law. Basic. Then we will solve a number of questions. Okay. Hope you have enjoyed the session, everyone. Harshita, you are getting 9.23. For which question? For this particular question? First assignment, na? This is the question. Okay. So what is the unit of 9.23? Because it is in milliampere and that's why Ix should be in milliampere. Yes. Okay then. तो okay, I will check and then inform you. Okay then. तो चलिए आज के लिए इतना ही काफी है. Thank you for attending the session, guys. Enjoy the day. Do all the assignments. Hope you are enjoying the session. Network. Only one thing is required. Practice, practice, practice. कोई भी ऐसे थे ये नॉवेल जैसा नहीं है. इट इज नॉट अ हिस्ट्री और ज्योग्राफी कि आप पढ़ रहे हो नॉवेल जैसे. आपको क्वेश्चन सॉल्व करना होगा. उसके बाद भी कोई डिफिकल्टी होगी तो बताइएगा. यू कैन फॉलो द बुक अलेक्जेंडर एंड व्हाट साडिकू, or you can also follow the other textbook if you have. Otherwise Alexander and Sadiku more than sufficient. Okay then, thank you, have a nice day.